All right, we're looking at Chapter 6 review from the Lock 5 textbook. And exercise or example 5. Manufacturer of pharmaceutical produces products, analyzes the specimen from each batch of a product to verify the concentration of the active ingredient. Chemical analysis is not perfectly precise, so repeated measurements of the same specimen give slightly different results. So the results of repeated measurements are known to follow a normal distribution quite closely, and we know the standard deviation of this distribution is known to be sigma is 0.0068 grams per liter. Management asks the laboratory to produce results accurate to within 0.005 plus or minus with 95% confidence. So the first thing I want to write is that 0.005, the plus or minus. Oh, that's not standard error. That's our margin of error. We're given the margin of error is to be plus or minus 0.005, and we want to be 95% confident in how many measures must be averaged to comply with this result. So I'm going to look at the formula worksheet, and I was on the second page. Tells us for sample size, because notice that we're looking for, well, what samples, how many measurements, how many samples must be averages. So now we are looking for sample size. And the formula for that is n has to be at least z star times sigma, all divided by the margin of error squared. So if I rewrite that for sample size, n needs to be greater than, I throw on this formula, z star times sigma, all divided by the margin of error. So if I want to fill in these details, we're given the margin of error to be 0.005. It doesn't matter if you use the plus or minus because we're going to square it out. And I know that sigma is 0.0065. The last thing we need to know is z star. And if we're looking for 95% confidence, that z star is a 1.96. And then we're going to multiply that times 0.0068. All right, and then I want to throw this in the calculator. 1.96 times 0.0068, all divided by 0.005, and then square that value, and that gets us to approximately 7.1. So if you don't forget for sample size, so we need a sample of at least 8 to be within 0.005 accuracy with 95% confidence. So don't forget on these, always round up to the next whole number, even if it's just barely above the integer. So it needs to be a whole number, sample size of at least 8.